Hey Bobcats, it's Mr. Peterson, and today things are going to get complex. I mean that not in the sense that things are going to get hard, because I think this stuff is pretty straightforward. I just mean we're going to be dealing with complex numbers. That's a little math humor for you. Anyway, uh, we were talking the other day about operations with complex numbers, and we learned about adding and subtracting with them. Today we're going to continue talking about multiplying and dividing. So we left off on this one. So before we head into it, though, I want to make a note that when we multiply imaginary or complex numbers, a lot of the properties that we learned in early math are still true, especially the distributive property. One thing you want to watch out, though, for is we need to remember that I is the square root of -1. And so if we have something like I squared, well, that's kind of like saying the square root of -1 squared. And whenever you take the square root of a number, but then square that, you wind up with just the number under the radical. So I squared is -1. So when you wind up with that in your problems, you want to make sure you convert that I squared into a -1. So just kind of be on the watch out for that. All right, so first up here we have 2i times a 3, and then we're going to do a 2i times a -5i. Remember, this is the same thing as plus a negative. All right, so let's start looking at that. 2i times 3, that would be 6i. And then a 2i times a -5i, well, that would be plus a -10i squared. And then, of course, I need to remember that I squared is really just a -1. So a little mini problem here. This is a -10 times a -1. So, which is going to be a positive 10. So we're left with 6i plus 10, but remember, we don't write it like that. We need to keep the real part out in front. So in its simplest form, this is 10 plus 6i. Okay, let's look at another one. We're going to just, this time we're going to FOIL it. So we'll do the 5 times the 4. That's going to be 20. And then the 5 times the, remember this is plus a negative, so 5 times a -3i, well, that would be plus a -15i. And then we'll do, remember this is plus a -6i, so we'll do these in green. A -6i times 4 would be plus a -24i. And then a -6 times a -3, that would be a positive 18i squared. Okay, red flag right there. Let's combine some of our like terms, clean this up a little bit. We would wind up with a 20 plus, and we can combine these two right here for a -39i, and then plus 18i squared. We need to remember that this is really times a -1, so this becomes a -18 when it's all said and done. So 20 plus -39i, and then plus a -18. Again, remember that this is -1 times 18. That's where we got this part right there. All right, so a little bit more combining of like terms. The -18 and the 20 would give us a positive 2 plus a -39i, or in totally simplest form, 2 minus 39i. Okay, I'm going to move these up to do these next ones. Let me erase all of this. Okay, so again, we're going to be doing some FOILing here. We'll do 7 times 7, which would be 49. And then 7 times a -2i, that would be plus a -14i. And then a 2i times a 7, that would be plus 14i. And then a 2i times a -2i, that would be plus a -4i squared. And again, I didn't say it this time, but I meant to do it. This is plus a negative. All right, so let's clean this up a little bit and combine some of our like terms. A negative 14i and a positive 14i, that's going to wind up becoming 0. And then we also need to remember that this I squared, that's negative 1. So as a little mini problem here, this is negative 4 times negative 1, which is going to wind up giving us a positive 4. So now we can clean up a little bit more here. We have a 49, and then the 0, which we're not going to count, plus 4, which we then could combine to give us 53 as our answer. All right, last one, D, 6i times 6i. So this is going to be 36i squared. But we need to remember that the I squared is negative 1. So this is really 36 times negative 1, which is negative 36. All right, why don't you guys try this one, and try this one, and try this one. All right, you might want to copy this down. This kind of shows you how when we raise I to higher powers, there's a pattern that's going to happen. Okay, so when we have I to the first power, that's just I. But when we have I squared, that's negative 1. When we have I to the third power right here, you see that's I squared times I, which is negative 1 times I, which would just wind up being a negative 1. And then we have I to the fourth, that's negative 1 times negative 1, which winds up being positive 1. Then here we have I, negative 1, positive 1, and then I, negative 1, positive 1. So the pattern that we should notice here is that if we wind up with a multiple of 4 as our exponent, 4, 8, and 12, we wind up with a positive 1. So that's just something you might want to make note of. All right, so simplifying powers of I. So here we have negative 3i to the 12th. And we need to remember our pattern that we saw on the previous page, that when we had multiples of 4, that wound up being a 1. 12 is a multiple of 4. So that means that I to the 12th power is really just 1. So this is going to wind up being a negative 3 times 1, which is negative 3. Okay. On B here, we need to remember again that pattern that it goes in multiples of 4. Every multiple of 4 is a positive 1. And then to look back at your table, the next one after that would be an I. So this one, if we think about this, 25, that's 1 after a multiple of 4. 24, of course, is a multiple of 4. So 1 after that would be just an I. So I to the 25th power is really just I. I to the 25th power is really just I. So let's look here. Why don't you guys try this one and this one. And then last example for today, remember that we can't have square roots in our denominator, and so we need to rationalize the denominator when we wind up with square roots in them. That's something we learned earlier in this year. And since I represents the square root of negative 1, we can't have I in our denominator. And you'll learn earlier in our chapter here in lesson 5.5 that to get rid of that, we would need to use the complex conjugate. So we're going to see that whenever we divide by complex numbers. So here, problem A, we have 3 plus 7i divided by 8i, so we need to multiply by the complex conjugate. So 3 plus 7i divided by 8i, we multiply by the complex conjugate, which would be negative 8i. So negative 8i, so all of this times this. And it's important to note that we're not changing the problem. What we're essentially doing is multiplying by 1 and getting an equivalent fraction that doesn't have a a radical in the denominator, or an I. So now we use the lesson that we learned in the previous example. This is going to be a negative 8 times a positive 8, which would be a negative 64I squared. And then in the numerator, we need to do some distribution. We would have a negative 24I, and then a negative plus a negative 56I squared. Okay, so we need a little bit of cleaning up to do. We need to remember that I squared is really just a negative 1. And so down here we're also going to be multiplying by negative 1. So we have a negative 24I, and then a negative 56 times a negative 1 would be a positive 56, so plus 56. And then a negative 64 times a negative 1 would be positive 64. So after we get there, we need to look and see what common factors we might have. They all share a common factor of 8. So we can factor an 8 out of both of them, the numerator and the denominator. So that would be a negative 3I plus 7 over 8. And then once we have it like that, we need to rewrite it so that our real numbers are first. So that would be 7 plus a negative 3I, all of that divided by 8. All right, and then let's do B. I realize I went into the space for B. I'm going to erase it. So we have 5 plus I divided by 2 minus 4I. So again, we need to multiply by the complex conjugate, which would be 2 plus 4I, 2 plus 4I. All right, and so we wind up with a little bit of FOILing to do. This becomes a 4. This becomes a positive 8I. This becomes a negative 8I, and those will just wind up canceling. And then this becomes a negative plus a negative 16I squared. In the numerator, this is a 10, and then this is a plus a 20I. This winds up being plus 2 more I, and then this winds up being plus 4I squared. All right, now we need to clean this up a little bit. We need to remember that these I squareds are really just times a negative 1. So I'm going to go ahead and do that step first. So we still have 10 plus 20I. Well, we can go ahead and combine. That's 22I. And then a 4 times a negative 1, that's going to be a negative 4 plus a negative 4. And then our denominator, we'll have the 4, and then these two will wind up canceling out and becoming a 0. But the negative 16 times the negative 1 is a positive 1, positive 16, so plus 16. All right, a little bit more combining of like terms. The 10 and the negative 4 can combine for a positive 6 plus 22I, all of that divided by 20. We can factor out a common 2 from all of that, and we would get 3 plus 11I over 10 as our final answer. All right, so why don't you guys try this one and this one, and we'll see you in class.